We will now look at indicator variables for categorical variables with just two categories. The canonical example may be gender with the values male and female. And so we can create two indicator variables. One, an indicator for male, where the variable takes the value 1 if the gender is equals to male and 0 if equals to female. And the same in reverse for female. Okay, so then we can look at our X matrix and the Y vector. Here, just a little example, toy example with fitness score is the outcome. And we are regressing on male, female, and age. And I have, as always, I have my column for the intercept in here. Okay, so we can input that into Stata or some other package. And of course, male and female depend on each other. So we can generate a new variable female equals 1 minus male, and then do the regression. In R, the syntax is slightly different, but the idea is the same. I have my fitness score and I regress on male, female, and age. Ooh, there's something red. Stata doesn't like this. Note, female omitted because of collinearity. What did it do down here? Female has a coefficient of 0 and standard error omitted and the rest omitted. What does R do? R has the same. They don't give a warning message, but everything here is missing, not available. So what's going on? The root of the problem is that the first column, the intercept, is the sum of the second and the third column. We know that male plus female is always 1, and the intercept is also always 1. So we have a linear dependency. And because of that, the matrix X transpose X does not have full rank and does not have an inverse. So specifically, what happens is the model is over-parameterized. It has one more parameter than it needs. And we have more than one solution. So the solution is not unique. And here on the right, I have put down two solutions that are completely equivalent with respect to this model. And basically what I've done here is here I have female equals 0 and constant 716. This is what the model originally suggested, kicking out female. And what I've done here is I've said, well, my constant is going to be 0. And I'm adding the 716 to the male and female indicators. So you can check that out. If you take any combination here, these two sets of coefficients are going to give you the same answer. Okay. So to avoid this issue, we just have to leave one indicator variable out. Rather than using both, we just use one of the two, and which one doesn't matter. Doesn't matter at all. The regression will give slightly different output, but the interpretation is going to be the same. So here is the regression output if I regress on female. And on the next page, I am comparing the regression output where this is the one from the previous page where I regress on female and age. And the other one would be where I regress male on age. What is the same is everything that relates to age is the same. Same coefficient, same standard error, same here. Now the standard error of the fitness of the coefficient for male and female is also the same. 46.5 here. The coefficients have opposite signs here, and the constant has changed, right? And the constant has changed because the constant now has a different meaning. In this model, the constant refers to not being a male at age 0. So it's a female at age 0. Whereas in this model, the constant refers to not being female at age 0. So it's the male at age 0. Yeah. Yeah, and that's basically what I just said. The expected fitness score for females at age 0 is beta 0 here. And here, the expected fitness score for females at age 0 is not beta 0, but beta 0 plus beta 1 was the indicator for female. Now, if you sum up beta 0 and beta 1 on the previous page, you are going to get beta 0 of the other model. Okay, one practical tip for naming variables. When you have a variable like gender, it seems totally normal to call it gender and define it as 1 when gender equals male and 1 when gender equals female, or the reverse, doesn't matter. I recommend that you always give a name of an indicator variable such that the name reveals what the coding is. When I call it gender, I don't know whether it's coded to male or to female. If instead I call it male, I know male is 1. And if I code it female, then I know female is 1. Good. So that brings us to a question. We have the same data as before. Different X matrix now. Same equation as before, same regression equation. Well, I guess we had several. No, it's not the same regression equation. It's slightly different. It has male and female, but not the intercept in here. The question for you is, which of these is right? And I will leave you to answer that.